Alrighty, gonna do this one live. Hi Grayson, Tiara, hi Raymond. Don't worry about me. From the 403 to the HAZ. Going to talk about rational expressions because I have 3 students in my class. It's Friday. We're having a good time. And they said, Mr. Nelson, we would love nothing more than to see the magic. What's really happening behind the camera on your amazing YouTube videos? And I was like, guys, yeah, I'll show you for sure. Let's do it. So I'm just trying to catch up here. I want to do a video on rational expressions, specifically around multiplying rational expressions and then finding NPVs. And what we're going to find is just like with integers, just like with fractions, multiplying is actually pretty easy. So we just have to follow some rules when we're multiplying rational expressions, or steps, rules that I kind of go with. The first is, we always try to factor everything in your initial problem. Try to factor everything, if you can. And so when we're doing that, the kind of little subset A is, we're looking for common factors first, and then after common factors, we're going to see if we can do, if it's a trinomial, and if we can do trinomial factorization after the common factors, and we can do that 2 ways, either product sum if there's no number in front of my x squared term, or we can use decomposition. And then once we do that, then we can take the NPVs, the non-permissible values. Hey Jesse.
Hey Mr. Nelson.
How you doing?
Supposedly I was supposed to come here for some shamrock.
Oh, you need a shamrock, yeah. It's they're right there and the pins are right there. And 3 is multiply. Multiplying fractions, we just multiply the numerator, multiply the denominator. And then 4 is simplify by canceling. See you later, buddy. Simplify like terms. Simplify by canceling terms that show up in the numerator and the denominator. So what does this actually look like in practice? Well, let's go for it. So let's say I had a problem like, I'm just going to jump right into it. Green just doesn't work. What color you guys want?
Red.
You want red? The color passion? Use the color passion. Okay, so we've got x squared minus 4 over x squared plus 25. And we're multiplying that with 2x squared plus 10x over x squared plus 2x. Okay, so the first thing I'm going to do is try to factor everything. So I'm going to start with this guy here. I'll notice 4 is a perfect square and there's no middle x term. So that's kind of a hint that this is a difference of squares. Is that the right thing? A difference of square or a trinomial. So this would be x plus 2, x minus 2. That's when we have a situation where we have a negative perfect square and no middle term. It's because we added 2x and subtracted 2x and get 0. So that's for this guy here. This guy on the bottom, I can't pull out any common factors, just like I couldn't up here. And that's a positive 25. So there's no way we can factor this because I could rewrite this as x squared plus 0x plus 25, and then I'd be looking for 2 numbers that multiply positive 25 and add to 0, and it's impossible. So that's going to stay the way it is, unfortunately, but maybe it'll work out. So that's going to be x squared plus 25. And then I'm multiplying. Now here, again, I'm going to start. Are there common factors? Well, I can pull out a 2x and then multiply that by x to get 2x squared and plus 5 here. I'm wondering if that's a typo in the textbook, but either way, we're just going to do what it says. And then we get here x. So here I have a common x. So I'm going to pull out my x, and it's going to be x plus 2. And I'm going to tell you what, I'm going to change this to a subtraction so it works out a little bit nicer, because I think that's what they intended in the first place. So if that's the case, then I can change this with x plus 5, x minus 5. Okay? So now we can see that everything's factored. There's no more trinomials left to be factored. There's nothing else I can do to anything else. That's where I want to be. That's where I want to start. So now I can jump into taking my NPVs. And I take my NPVs just on my denominator, right? And it's the same thing, but I'm going to look at the denominator of both fractions or both rational expressions. So here my NPVs I can see are going to be that x cannot equal 0. Basically, we're looking for any x that is going to make the denominator 0. So if x is 0, 0 times 0 plus 2 is going to be 0. So x cannot be 0. Negative 2 plus 2 will make 0, and then negative 2 times 0. So it can't be negative 2, because that will make this 0. And then if I have negative 5 or positive 5, that will make the bottom here 0 as well. So those are my NPVs. And that's pretty much that's the bulk of it. And then I can rewrite this as one long multiplication over everything. So I'm going to pull that 2x, put it in front, just because I like that to be like that. So I get 2x plus 5 times x plus 2 times x minus 2. Right? All I've really done is just erase that and made it multiply the top and the bottom. That's the same. That's not a division. Okay? That's all I've really done. I'm just kind of rewriting this. And that's all over x plus 2 times x plus 5 times x minus 5. It does not matter what order you put your multiplication, because 3 times 4 times 2 is the same as 2 times 3 times 4 is the same as 4 times 2 times 3. It doesn't matter what order you multiply things in. So I always like to have my non-binomials out in front like that. That's just how I like to do it. So then I've multiplied, now I'm going to simplify. I've got an x plus 2 there and an x plus 2 there. X plus 2 divided by x plus 2 is simply 1, so that's why we can cancel it. And then I also have an x plus 5 here and an x plus 5 there, and I have an x on the top and the bottom, so I can actually cancel my x's there. And I can rewrite this as 2x minus 2 over x minus 5, where x cannot equal, okay, I'm going to write it, I'm going to write it right here. Okay, is equal to 2x minus 2 over x minus 5, where x cannot equal 0, negative 2, negative 5, and 5. That is my answer. We take the NPVs before we cancel anything. That's really important. You guys look like you're actually learning something. Yeah. Thank you for letting me do this, guys. That's there. So let's do a couple more examples, maybe slightly more difficult, and then we'll be done here. Okay, so let's try this guy. I've got d squared plus 3d plus 2 over 2d plus 2 times 2d plus 6 over d squared plus 5d plus 6. Okay? So the first thing I'm going to do is I'm going to try to factor everything, and I'm going to start by looking for common factors. Any common factors here? No. But it's a trinomial, so I know I'm going to factor this one as a trinomial. I'm looking for two numbers that multiply to 2 and add to 3. Well, those are going to be 2 and 3, 2 and 1. 2 times 1 makes 2, 2 plus 1 makes 3. So that's how I factor that one. Down here, I'm going to start with my common factors. I have a common factor of 2. So I'm going to pull out a 2, and it's going to be d plus 1 there. And then I'm multiplying by, again here, common factor of 2. And that's going to be d plus 3. 2 times d makes 2d. 2 times 3 makes plus 6. And then here, it's a trinomial. There's no common factors. And I'm looking for two numbers that multiply to 6 and add to 5. And that's going to be 3 and 2. 3 and 2 multiply to 6 and add to 5. So d plus 2, d plus 3. Okay? Now, so I've done step 1. And now I'm going to take my NPVs from the denominator. And by doing that, I find that my NPVs are d cannot be, what values of d will make denominators here 0? Well, if d is negative 1 plus 1 is 0. 0 times 2 is 0. If d is negative 2, negative 2 plus 2 is 0. 0 times negative 2 plus 3 is still 0. And then if d is negative 3, that's the denominator. Negative 3 plus 3 is 0. And then 0 times negative 3 plus 2 is going to be 0. So those are my non-permissible values. Now I can go through and I can multiply, and I'm just going to make this one long equation. D plus 1, d plus 2, holy crap, d plus 3. Everything's going to cancel here. This is going to be 1. The answer here is going to be uno. It is what it is. Hopefully I haven't screwed up, but it looks like that's what's going to happen. So d plus 1 cancels with d plus 1, d plus 2 cancels with d plus 2, d plus 3 cancels with d plus 3, and then 2 divided by 2 is uno, which is a funny answer. It's 1. It's 1 where b cannot equal negative 1, negative 2, negative 3. This problem's making me feel insecure, so I'm going to actually open up the answers to make sure. That's what it's here for. 352 numero minor. That's exactly what the answer is. 1, where d cannot equal negative 3, negative 2, negative 1. Okay, no, there it is. There it is. That is the answer here. Come in. Oh yeah, they're right here.
Yeah, I wasn't in my classroom.
No problem, bud. There you are.
Thank you.
Okay. We've got students coming in today because it's Clover Day. I've got coffee spilled on my thing. It's Clover Day, which means that, like Hearts Day on Valentine's Day, it's a really cool thing we do here. Basically, all the boys get clovers today, and girls are trying to get their clovers by having them talk to them. So we're not supposed to talk to the girls in unstructured time, so in the breaks. And then the girl that collects the most clovers, just like on Valentine's Day, the boy that collects most hearts, wins a sweet prize. They win a flight to Wuhan, China. All expenses paid. Thought I was going to get a laugh out of that one, but nothing. Crickets. Crickets. Is this thing on? Crickets. Okay, let's do one more problem where we have a little bit of decomposition involved. Oh, that's gross. Well, no, there is no decomposition involved. I'm just going to do one more for fun. One more for fun. Let's say I had 3a plus 3b over, this is my bad book, over 8 multiplied with no, I'm not doing this one. This one's weird. I'm going to do this one right here, and we're going to have a great time. We're just going to have a great time. Minus 8y. Actually, I'm trying to find one with decomposition. And you know what? I'm going to do this one. I'm just going to get crazy. So I've got 2x squared plus 9x plus 10 over x squared minus 3x minus 40 times x squared plus 9x plus 20 over 2x squared plus 5x. Okay, so the first step is try to factor everything. Common factors here, there's no common factors. I can't pull out any common numbers, and there's no common variables. Same thing here, so this one I'm going to do decomposition because I have a number in front of my x squared term. This one will just be product sum. So we'll go through both of those. Here, this is a trinomial, there's no common factors, so I'm going to use product sum here. And here, I'm going to be able to pull out an x, and it'll be x times 2x plus 5. But we'll get there. So let's start up here with the 2x squared plus 9x plus 10. Okay? This is decomposition. I have to use decomposition for this one because I have that 2 there. So what I do for decomposition is I'm looking for I'm going to multiply the x squared term and the constant there. And so now I'm looking for 2 numbers that multiply to 20, to whatever those multiply to, and add to the 9. So add to 9. And when I do that, I would find that those 2 numbers are 4 and 5, positive 4 and 5. So in decomposition, I'm going to replace the 9x with these 2. And it doesn't matter what order I put them in, but usually there's one way that's going to be a little bit easier. So I notice that 4 and 2 they have a common factor of 2. So I'm going to put the 4 beside the 2. And what does that look like? So now I'm going to go 2. Next. Come on, red. Terrible. Just grabbed a whole bunch. Terrible. Oh, there they are. Okay. 2x squared plus 4x plus 5x plus 10. Okay, so I've replaced 9x with 4x plus 5x, but I haven't changed my equation there. Now I'm going to factor this part using common factor first, and I can pull out a 2x. 2x times x plus 2 will make 2x squared plus 4x. And then whatever I came up with over here in the bracket, I'm going to put in the bracket on this side. And I'm going to find that I have to multiply x plus 2 by positive 5 to get back to here. So now, x plus 2 is common. So I can actually factor out an x plus 2, factoring out the x plus 2, and the x plus 2 has to be multiplied by 2x plus 5. And that is how we factor using decomposition. Okay, the 2x plus 5 becomes a factor, or binomial, and then whatever was in here. I explained this in more detail in another video on decomposition, so I'm not going to get into it here. But that's the hardest thing we're really going to have to do in this problem. So I'm going to rewrite my equation using now x plus 2, 2x plus 5 on the top. Now I'm going to erase all this because I need the space. Now I'm using product sum here. Two numbers that multiply to negative 40 and add to negative 3. So two numbers that multiply to negative 40 and add to 3. And those would be negative 8 and positive 5. Negative 8 times 5 is negative 40. Negative 8 plus 5 is negative 3. So my factors here are x minus 8, x plus 5, and then I'm going to multiply with two numbers that multiply to 20 and add to 9 are going to be x plus 5, x plus 4. Just using the same product sum method, two numbers now that multiply to positive 20 and add to 9. Okay, now down here, I'm looking for common factors. And I notice that I can pull out an x. They have an x in common. X times 2x plus 5. And you can already see that, oh look, they're showing up both there and there. So I've done my factoring. That's kind of the hardest part. Now I'm going to do my NPVs. My NPVs are on the denominator. 0. So x cannot equal 0, because if x is 0, that's going to be 0. To figure this one out, I'm going to make 2x plus 5 equal to 0. And I'm going to solve to figure out what value for x will make this side 0, like make this statement true. So 2x plus 5, 2x is equal to negative 5. I'm going to move the 5 over and then divide by 2. So I get x is equal to negative 5 halves. So negative 5 halves. I'm saying what values for x will make 2x plus 5 equal to 0. Okay, here it's negative 5 plus 5 will make 0, and 8 minus 8 will make 0. So there's my NPVs. Now I can multiply, and I'm just gonna erase that, and I'm gonna put the multiplication on up here and over here. Okay, I'm gonna make it a big dot. That's my multiplication, and I'm just gonna go ahead and cancel right now because I can see that that's gonna cancel there, and x plus 5 is gonna cancel there. And that's all the canceling I can do. So now I'm gonna rewrite this as an expression: x plus 2, x plus 4, all over x times x minus 8, where x cannot equal negative 5, negative 5 halves, 0, and 8. And that is my answer. Okay, that is all I'm going to do for multiplication. I think you can handle it from there. Thank you very much. Thank you, guys.